delta x. I started here at A, I moved into delta x width, and now I'm sitting right here on that x value. What is that x value? It's equals delta x. And all that is known. A is known, and B and A are known, and N is known, so those are all computable. You'll know what that value is. You see what I'm saying? You'll know what that x location is. So A plus delta x is the next one. So f of A plus delta x times the width of delta x. That's the height, there's the width. So the next one should be pretty obvious now. A plus 2 delta x, that's right. And now you see the pattern. What is the pattern? Increase by 1 each time. All you do is slap in another delta x. Just go one step further. Just go one step further, plug it into the function, right? We should go write this more concisely now using our sigma notation. It's f of A plus some number of delta x's times delta x. So now what does I go from and to?
It goes from A to B.
Careful. We did not write A plus A delta x here, right?
You put the B at the top and you put I equals A, right?
We'll take Lee's suggestion. 0 to 3. In this particular problem, you're going to think about what it says. So I take this expression, I plug in 0. So that reads this one, doesn't it? Then I plug in 1. That reads this one. I plug in 2. That reads this one. Plug in 3. That reads this one. What does sigma mean? Add. So this expression right before it is the exact same as that one in sigma notation. Right? Okay. And now, what I like to do is make it a little more abstract and say, it didn't tell me how many rectangles to use. So I'm going to use n of them. So no matter how many rectangles you want to use, here's your formula right here. You're going to apply this formula for the left endpoint problem. Okay? You see it in action, it'll be much clearer, right? We haven't done a concrete example yet. I just want to get the formula board so you can apply it when we start doing some more concrete examples. Okay? You want to do one now, or can we show you the right points? Do a quick example, concrete example? Okay. The left endpoint problem from the textbook. Number 15. Number 15. It asks us to do both left and right endpoints. We'll do the left one first, we'll do the right one in a second. Use the figures, use the figures to help that. Okay, so the picture they have here the function is x plus 1. It's a linear function. And the interval is from 1 to 6. So I first have to draw that. So let's see, 1, 2, 3, 4, 6. So I need y to go up to what, 7 approximately? 1, 2, 3, 4, 5, 6, 7. And it goes from 1, 2 to 6, 7. Is that right? Okay, so we're supposed to approximate the area under the curve using left endpoints. I mean, there's the area under the curve.
Like for these problems, like if you start to see concrete shapes coming out of them,
I picked to use the example, Raja.
Yeah, like
I picked to use the example. Make you feel comfy with it. Don't get all excited, right? They're not going to be like that. They're going to be more like that thing, right? All curvy and wavy and no specific regular polygonal shapes coming out, all right? All right. Yes, I understand. This is a rectangle with a triangle on top of it. I know, right? Don't worry about it. So, if we approximate using left endpoints, just to draw the picture firstly. So that means this is the start of rectangle 1. Okay? Hold on, how many rectangles can we use? 6. Yeah, n equals 5. N equals 5, so. N equals 5, they tell us, which makes sense. They gave us exactly the increments that are the.
1.
Yeah, what do you call that? The,
Increments of 1.
right, the scale. Scale of the picture itself, right? All right, so there is the height of first rectangle. So just draw it over and then go down there. Right? First side, second rectangle. What do you say? Hold on, let me get the picture, man. Yeah, so then you go here to 3, scoot over here, and then climb down. There, there's that one, right? And then go up from there. That must be the height of the next rectangle, right? Going. Okay. Everybody all right so far with our picture? Yeah? Oops. There we go. That's the picture.
Is it underestimation?
Certainly is an underestimation, right? Total underestimation. Nothing is canceling at all, right?
Does concavity have to do with anything?
Absolutely.
Okay.
Yeah. All right. And which endpoints you use. The concavity and which endpoints you decide to use in the approximation determine a lot about over and underestimation.
Oh yeah, if the concavity is like down. It shoots up. Well, I mean, it depends where you're putting the lines. If it's under the curve, the slope's heading upward. And if it's those lines under, that's an under approximation. And if it's heading down.
If you were using left, but if
yeah.
you're using right, it would be
the opposite.
Right. All right. So now using our formula. You can easily confuse this about the formula, but I want to use the formula to show how it functions. So Rosales told us that delta x was 1, which is true from the scale again. But just to write the formula, 6 minus 1, b minus a over 5, that is certainly 1. All right, so now we're going to write this out with our summation notation there. So for left endpoints, approximation is going to be the sum going from what? Where to where? What to what? Should be more careful this one. We had a 3 up there, it was 4. It's in minus 1, I apologize.
Oh, it's n minus 1?
It is, yeah. I wrote that, yeah, sorry about that.
Let me write that.
Wait, what did you write? This should have been n minus 1. I wrote in because I was thinking about I want to do it for any arbitrary n value, so I wrote n, but the formula should have n minus 1. Because if you start at 0 and go to n minus 1, that's in increments. That's in subintervals. If you start at 1 and go to n, that's also n, right? If I start at 0 and go to n, that's n plus 1 increments. I've added an extra rectangle here I don't want, okay? So it's 0 to n minus 1 for left endpoint. My apologies. So we should have here, what, 0 to what? 0 to 4? 4, n minus 1. Oh, see, I ruined you already.
Sorry, I was looking at the 6, the 1 to 6.
Okay, that gives us 5 intervals over which we are adding up rectangles, right? The 0th interval, sorry, you look tired, man. The first, that tie's cutting off some circulation in your head. The 3rd and the 4th, right? So 0 through 4 is 5. Okay, so we have 5 subintervals. So 0 to 4 makes sense. And now for our formula, f is what? It's x plus 1. I'm going to write just the symbol first. So f of a, what is a in our problem? 1.